All right, hi everybody. Sorry about the technical difficulties. So I'm Dave Ferguson. I work for Qualys. So my role at Qualys is a solution architect for the web application security products that we have. I've had a lot of different roles here, including a developer, consultant. I work for an enterprise security. And now I help with our web app scanning products, help our customers, prospects, in terms of getting them up and running, deploying scanning programs, and so forth. So what I'm going to talk about today is a list for better application security. However, it's not the list that you probably are familiar with, which is the OWASP Top 10. So first I'm going to talk about the list that I'm not going to talk about. I want to cover just the OWASP Top 10 2013 edition real quickly. I'm sure most everyone is familiar with this by now, since it's been around for 4 years now. What we have here is a top 10 list of most critical risk to web applications. And it hasn't really changed since 2013 until this year. And so I have more on that in a minute. So the thing about the OWASP Top 10 is it's really been adopted almost as a standard. It was never really meant to be a standard, but the PCI DSS, for example, has adopted the OWASP Top 10, saying no payment applications should be vulnerable to any of these types of issues. So I want to talk about the release candidate that came out just a few weeks ago for the 2017 edition of the OWASP Top 10. And it's causing a lot of controversy and confusion, to be honest. So some of this changes real quick. Not a lot of changes, but some of the key differences here are that invalidated redirects and forwards, which is A10, has been dropped. By the way, this is all tentative. It's not finalized by any means, but this is what the release candidate has. So the unvalidated redirects and forwards has been dropped. The A4 and A7, which both relate to authorization issues, have been combined into one, A4, which is called broken access control. I'm okay with both of those, and I think most everybody in the AppSec world kind of has no problem with those. The things that are causing controversy are the new ones, especially this new A7 here called insufficient attack protection. So insufficient attack protection, it's completely different than any other type of OWASP Top 10 issue in the past, in that this is not really a vulnerability or a risk. It's a thing that, it's really like a way of protecting applications that may have vulnerabilities. So it's not about fixing vulnerabilities or knowing that you have them. It's just about protecting applications. So it's kind of a paradigm shift in a way, and there is a lot of controversy. Just if you look at the OWASP Top 10 mailing list, you'll see some of the comments that have been made. And there's a blog post by Chris Ng, who I used to work with, on dark reading about this and some of his concerns with it, which I tend to agree with, to be honest. So let me talk about A10 for a minute, underprotected APIs. This is kind of interesting as well because it's not a vulnerability. It's basically saying, okay, A1 through A9, those apply also to APIs. So it doesn't, both of these kind of like are just a different way of dealing with this. And the thing is with the OWASP Top 10, any change could have a huge business impact out there because of the fact that PCI and others use the OWASP Top 10 as kind of a standard. And so all of a sudden, if you've added insufficient attack protection and underprotected APIs, you're talking about possibly a whole shift in needing to guard against these things. And APIs is great as far as protecting them, but essentially, it seems redundant to me because if you're saying that the OWASP Top 10 is just for web applications, you can just say that and say, oh, and also it's for APIs. So you don't need an actual item in the OWASP Top 10 saying also protect APIs. Just my thoughts on it, but we'll see how the final version comes out. But A7, the new A7 here being proposed, if you think about it, if we have underprotected applications, why don't we also have insufficient AppSec funding? I mean, that's a risk. What about inadequate executive buy-in for having a secure SDLC? These are all sort of factors that go into securing applications. So should they be on the OWASP top 10 also? No bug bounty program, understaffed on-call IR department, lack of cyber threat attack 3D Blinky world map. All these could be risks that could be part of the OWASP 10. Okay, the mission of the OWASP 10 is not real clear right now. So we'll see how the comments work out. And I also need to mention that OWASP, of course, is supposed to be an open organization, vendor-free, vendor-neutral, agnostic. But there's some thoughts that under protected, or the insufficient attack protection, A7, that specifically benefits a certain class of vendors out there. Specifically, anyone who has a product that includes runtime application self-protection or web app firewall, anything that protects the application. If there's a product out there that fits that or protects against A7, they're going to benefit greatly if that gets added to the OWASP top 10. So that's one of the pieces of controversy out there. Okay, so I'm really done talking about the OWASP top 10 now. I want to get into a different list for better AppSec. And the list I'm going to talk about is the OWASP top 10 proactive controls. This particular project, again, it's from OWASP, but it's really targeted more at developers, and it's a way to assure that development teams can build in proactively protections and fight vulnerabilities in their applications. It first appeared in 2014, so it's been around about 3 years now. It's on version 2 right now. An update is coming later this year, so it's actively being worked on. And the leaders on this project are, some of you may know Jim Manico, also Jim Bird and Katie Anton, are the 3 kind of primary contributors to this project. And so as part of this talk, I actually reached out to them and talked to them about it. They have some really good ideas for this. And one of the reasons I wanted to do the talk today was just to make it known that there's actually a better list out there. If your goal is to have your developers in your organization build more secure applications, they should really be looking at this list versus the OWASP top 10, even without all the controversy that's going on right now. So the OWASP top 10 proactive controls is a list of really techniques, security techniques, that need to be included or should be included in every development project. And it's listed in order of importance. So C1 is the first control, being most important in descending order to C10. And like I said, the target audience is developers. So I did want to mention also that the proactive controls, there's really a lot of supporting documentation for implementing the controls, and the vast majority of that is going to be found in the OWASP cheat sheets. I didn't even list them all here, but there's a very large number of cheat sheets on different topics that if you need to secure your application against SQL injection, how do you do that? There's a cheat sheet for that. There's a cheat sheet for almost anything you can think of. I was the original author of the Forgot Password cheat sheet, which is up here somewhere. But this has been an effort by a lot of smart AppSec people, and it's like a great place to go, especially for developers, to reference specific topics. All right, so let's dive into the proactive controls. I'm going to go in reverse order here. So we're going to start with control number 10, which is error and exception handling. So what's the purpose behind this? Well, it's probably pretty obvious, but it's to prevent disclosure of any kind of technical information that could help attackers. It doesn't necessarily have to be technical information about infrastructure. Although things like stack traces being returned to the user in a browser, that's very helpful to know what software is running on the server, and maybe you can attack it. But it's also related to things like application-specific data. Account enumeration is the big one. Like when you have a login page in a web app, it shouldn't be disclosing whether or not the username that was tried is a valid username. It should just be a generic error message. So that's if it does disclose whether it's a valid username, then you're talking about account enumeration. So that's a type of error message that needs to be thought of during the design and development phase. So you want to be very careful in error messages that are returned to users. They need to be very generic, and the error handling mechanism should really be centralized. You don't want to have each developer roll their own type of exception handling. It's better to have a centralized mechanism for that. And if there are errors, you can certainly log the details of the error for debugging or troubleshooting, but you should log that on the server side, and associate some sort of a reference number to that. And then you could display the reference number to the user so they could report that as an error. And then you could look up the details on the server side, but you shouldn't really be exposing that information to users. I have pen tested applications where the developers tried to do that, where they tried to hide the debugging or the stack traces in the HTML and an HTML comment. So you don't really see the error looking at the web page, but if you do view source on the page, you can see the whole stack trace. It doesn't really work. That's not the idea. All right, I'm going to move on now to control number 9, which is leverage security frameworks and libraries. So the important thing here is that any kind of web development framework or a platform that developers are using, there's going to be security features within that platform or that framework. So why not take advantage of them? It doesn't cost anything. Typically, it's just a configuration flag or maybe a few lines of code. And so you get this security for free in your application, not a lot of extra work. So some examples of this would be things like anti-cross-site request forgery tokens. There's all kind of PHP, Ruby on Rails, Java, Apache struts. They all have ways to prevent cross-site request forgery by implementing a token in the forms. Also, error handling mechanisms, which we just talked about. Configuration is available for handling unexpected errors. Session timeouts is another one. Any kind of web session should time out after a certain amount of inactivity. That's all configurable in the frameworks. Cookie configuration. This is very easy. It raises the bar for attackers, but making sure your cookies are marked with secure, making sure they're marked with HTTP only. If there's any sensitive data being stored in that cookie, which hopefully it's not, but if you need to do that, you should be encrypting the contents of the cookie. Output encoding, a lot of the frameworks, when you're writing an HTML page, it automatically will encode the output to prevent cross-site scripting. And ORM would be object or relational mapping. So that's a SQL injection defense. Many of the development frameworks provide that out of the box, and you can be, if so, or Hibernate would be one. You can be protected against SQL injection. There's also third-party libraries. So maybe your native development platform doesn't have what you need. There are third-party security libraries you can add to the application that may have some of the features that you need. Listed some examples here. Shiro is an authorization framework for different permissions, enforcing permissions on different users and their roles. And there's another library from OWASP called eSAPI. So these are all available and could be used as needed. There is one big caveat to this, though. Frameworks and libraries themselves can have vulnerabilities. And when they do, and they're announced, it can often set people to scrambling. So some recent examples would be Apache struts. Struts had some remote code execution vulnerabilities. Well, over many years, they occasionally have this happen, so it seems to be never ending. But just about a month ago, it had some very serious remote code execution vulnerabilities in the Struts 2 framework. So a lot of our customers were scrambling to get those patched and trying to use our product to scan to find if they had this vulnerability. So you got to be vigilant about the advisories. Know what you're using, so be familiar with what's in your environment, and you can use another OWASP tool for that. It's called OWASP Dependency Check. That's a free tool you can download. It'll scan or analyze your application at the code level and determine what libraries you're using so you can know what you have. All right, I'm going to move on to control number 8 now, which is implement logging and intrusion detection. So this is, talk about logging first. So logging is, from a security point of view, is not just about debugging. There should be some logs in place to help understand when and how your application is being attacked. This is kind of similar to the A7 insufficient attack protection that I showed in the regular top 10, the new regular top 10. So remember, these are proactive controls. We're not talking about risks here. We're saying these are things that developers should proactively think about on every development project, just to make more secure applications in the end. So with logging, it provides a lot of benefits, not just knowing when and how you're being attacked, but if you do get attacked, you can be alerted. Some sort of monitoring can be set up. If something happens where you get breached, there may be some forensics information available to help with the logging that you do. So when the logging is done, you really should, list the timestamp, when it occurred, the event type, the source IP, and the user ID, if needed, the user ID associated with that. And then you can essentially, as you're developing the application, the developers know where the important pieces are, so you can use that as a guide to know what to log and where to log it and how much to log. And as usual, you want to avoid logging sensitive data. You don't want to have credit card numbers or passwords in your logs. So think about that. Also log injection. There's a type of vulnerability called log injection where a user can enter a carriage return line feed, for example, and then basically fake log inputs in the logs. So that's important to avoid. You want to validate the data, encode the data, prevent the log injection vulnerabilities. And then there is, again, a cheat sheet for logging, so that is helpful. So all these cheat sheets are supporting these proactive controls. Now, the intrusion detection piece of this is kind of interesting. I once pen tested a web application that it was very frustrating as a pen tester because every time I would try to tamper with data in the request to see if I could elicit some sort of exploit of a cross-site scripting or SQL injection or anything like that, the application would log me out, and it would kill my session. So I would have to start over again. And I always, to this day, that was probably 8 years ago. To this day, I remember thinking, if all applications did that, that would make it much more difficult for the web app hackers out there, because it's just you can't methodically go through and test this thing because you keep getting killed. Your session keeps getting killed. So that's the idea. An OWASP app sensor is a way to implement this kind of functionality. It's built for sensing when there might be an attack, and then basically taking some sort of action, whether that's killing the session or something else. Maybe it's just logging. But App Sensor is a way to implement this kind of intrusion detection within your web application. So where would you use this? So there's a couple examples, or 3 examples I have up here. One would be if your application receives input that comes from a drop-down menu in the web page, but the input received is not one of the choices in the drop-down menu. Okay, well, a normal user, that would never happen. But someone testing your application or maybe trying to look for weaknesses is going to try to exploit that by sending in different data for that particular parameter. So that's a clue that maybe this application is being attacked by this user. And so you could block that or kill their session or do something else. Similarly, if you have a non-numeric input on an input field, maybe you have JavaScript or your JavaScript framework in the browser enforces numeric values or digits. But suddenly your application on the server side starts getting input that's not numeric. That's another clue that there may be an attack or at least a pen test going on. And then also hidden input fields. So sometimes HTML forms have dozens and dozens of hidden input fields in them. Again, a normal user, those values would never change. whatever the value is, it's going to come into the server that way. But if the values start coming in differently, even if it's not just SQL injection attack strings, maybe it's just regular data, but that was different than set by the application, that's another clue that you could be under attack. Control number 7 is protect data. So that's pretty generic sounding, right? So what does that mean? Well, it means a lot of different things, to be honest. One of the most obvious is encryption of data. Encryption of data at rest, encryption of data in transit. In transit, of course, we're talking about TLS, HTTPS type of communication. It's required for untrusted networks. So over the internet, PCI, for example, requires that to be done. But you should also maybe consider this encryption for internal traffic as well. We know that Google and Microsoft and other companies like that, once the NSA revelations came out, they started encrypting their internal traffic in their data centers. So that's something that you should consider as well. Encrypting data at rest, very easy sounding, but not so easy in practice. You want to understand what data needs to be encrypted. You want to use vetted algorithms, peer-reviewed crypto libraries. All these things are important. You don't want to roll your own crypto solution. And then the key management aspect of it is also huge because you have to make sure your keys are not hard-coded, exposed, rotated, so forth. There's another cheat sheet for this, of course. So this is just kind of scratching the surface of that topic. Some other aspects of protecting data that may not be as obvious as encryption is storing passwords securely. There's a cheat sheet for that. You don't want to use symmetric encryption for storing passwords. Password storage shouldn't be reversible, which symmetric encryption allows. Also, protecting data means avoiding sensitive data appearing in cookies, URLs, browsers, and HTML5 local storage. So before HTML5, the only way a server-side web app could store data on a client side was really through cookies or something fancy like Flash cookies. But with HTML5, there's a whole framework around servers being able to store data on the client side, and that's called HTML5 local storage. So you have to be careful you're not storing anything sensitive in that location. Log files on the server, temp files, even memory on a server. PCI doesn't like to have credit card numbers and things in the memory on the server, so there's ways to kind of clean that out. And then mobile devices, mobile apps. I haven't really talked much about mobile apps yet, but a lot of these same proactive controls apply to mobile apps as well. Obviously, you can store data on a mobile device. Not recommended, and you have to be careful with that so you're not exposing that data. Implement access controls. All right, so control number 6 is implementing access controls. So what we're really talking about here is authorization. Authorization, of course, different than authentication. Authorization is enforcing permissions on entities that have already been authenticated. So you need to have access controls to avoid things like horizontal and vertical privilege escalation, forced browsing attacks, things like that. So in the proactive controls document, which you can download on the website, they make it really clear that the design or the model of authorization and access control should really be designed at the outset of the project. It's really difficult to bolt on an authorization model after it's already been developed. It becomes spaghetti code often in that scenario. So best practices there are really to route all your requests through a centralized security check and do a default deny so that if the no information is provided, then access should not be granted. And then you have to check, and I know we do this in our Qualys product, but you have to check the the action that the user is trying to do is one check that needs to be done, but also the object being acted upon, you need to make sure that the user has permission for that particular object. So some code here, examples. The recommendation is to enforce separately the access control decision from the actual decision-making process. So in other words, let's say you have a method called hasAccess. Every user object has a method called hasAccess. And then you pass in the particular action being requested. So that's preferred over the second model here, where you're basically checking the user role every single time. So in this case, the access control decision-making happens in the hasAccess method, whereas here, it's all happening in one place. The decision of whether or not to allow and the enforcement is happening together here. With this model, it's much more maintainable. Code auditing is much easier with this first model. Control number 5 is implement identity and authentication controls. So similar to access controls, but now we're talking about authentication. So this is more broad than that, though, because authentication is more than just username and password. Please authenticate me. It also encompasses session management, password storage and complexity, and forgot password functionality, which is something near and dear to my heart since I wrote the cheat sheet on that. But now each one of these is like whole topic, an hour-long talk in itself. So it's just kind of scratching the surface. For example, just picking session management. All kinds of best practices, proactive steps you can do in your application to make sure that session management is secure. For example, you should store the session token in a cookie. You shouldn't store it in a URL, for example. You don't want to expose session tokens in URLs. You got to make sure the token is cryptographically strong. You need to have an inactivity timeout. Also, an absolute timeout. So one of the things that Google does, for example, is you may be logged in to your Gmail, but maybe once a month or something, it forces you to log in again and supply your credentials. So that's an absolute timeout. And it's something that it's a best practice saying, okay, I know that you have a valid token, but this token has been existing for like a month. So now it's I'm going to actually time you out, and you have to log in again. Another best practice for session management is creating a new session token when you log in. So the idea is that maybe somebody was able to compromise your session token and hijack your session prior to authentication. And then once you log in, they've got access to your account. If you take the step in your web app to generate a new token upon successful login and invalidate the previous one, you're going to be protected against that kind of attack. Then there's cookie attributes around session management. It needs to be secure, HTTP only, same site. Same site you may not be familiar with. That's a new attribute of a cookie that browsers are just starting now to support. Chrome being the first one. Same site is an attribute of a cookie that's going to quash cross-site request forgery. So you're going to start to see that probably show up in assessment reports where a cookie is missing the same site attribute. So wanted to mention that since that's new and everyone may not be familiar. Control number 4, validate all inputs. So this is probably kind of a no-brainer. I think everyone's familiar with validating inputs. Any data that a user can influence in any way needs to be validated. So it's not just visible inputs on a web page. It's really anything in the HTTP request. Whether that's in the body of the request, the URL, the headers, anything in that request can be forged or tampered with, so it needs to be validated. There's a concept of syntactic validation, which is essentially, does the format of the data match what I expect? So if it's a 10-digit account number, is the data actually 10 digits that I receive as input? So that's a syntactic validation. Then there's semantic validation, which is that meaningful for the user? So that kind of relates to what I was saying earlier, like, is the action being requested, is that actually valid for that user? So that's, you need to validate that that request is permitted for the object that's being acted upon. That's semantic validation. Can anyone tell me what type of data validation this is? He's on a unicycle, by the way. This is blacklisting. This is blacklisting input validation. And so he's flown right by, no problems. Types of validating data is blacklisting approach. Better than nothing, but again, you may have forgotten something, so you can get around it. Whitelisting, much more secure. Usually, if you can use regular expressions, that's a great way to do whitelisting data validation, and it's the most secure way to do it. Also, you've got to do the input validation on the server side. You can't expect something in the browser that's validating your data to help with security. Now, there's nothing wrong with it. You can certainly validate data on the client side in the browser, but again, it doesn't do anything for security. That can be bypassed very easily. Just use an HTTP proxy like Burp or Zap or something like that. Oh, and now also keep in mind that just because data has been validated, thoroughly, rigorously validated, it doesn't mean it's safe. A single tick or an apostrophe in a name, that's a valid character, for O'Reilly and names like that. But it's also a dangerous character because it could, lead to SQL injection. So keep that in mind. Validating data, hugely important, but not necessarily the end-all as far as meaning the data is safe to use. So the next step in making sure data is safe to use would be encode data. So that's control number 3. And so this is going to give you powerful protection against many attacks, especially cross-site scripting. This is where the data is converted to an equivalent form that's no longer dangerous for the targeted interpreter, whether that interpreter is a browser or a database. Or you encode the special characters that appear within the data. And you need to encode it, at least for cross-site scripting, you need to encode that data just as it's added to the HTML. So that's called output encoding. It's pretty tricky, though. There's different types of coding, a lot of different types of encoding. Some examples, just in the browser world or the HTML world, would be regular HTML encoding. And so I put some examples of that down here. This is HTML encoding. That's different than URL encoding. URL encoding is different. If your data is going into a URL, you need to use URL encoding. It's also different than JavaScript escaping. JavaScript escaping is all different syntax. So it's not easy, and there's libraries to help with this encoding so developers don't make mistakes. OWASP has some libraries, encoding libraries to help with that. A lot of the frameworks or platforms that developers are using have these built-in encoding libraries. But if they don't do the encoding, then you could be vulnerable. So that's why this proactive control is so high on the list. We're up to number 3 now. Last thing is, don't forget that mobile apps, back to mobile apps, they use what's called web view. So that's essentially a web page in the mobile app itself. And so you can still have the cross-site scripting issues within a web view in a mobile app. So you have to remember that if your mobile app developers are doing that. All right, we're down to the top 2 now. We're up to control number 2, which is parameterized queries. And so the purpose is to prevent SQL injection. I'm sure most of you have seen this comic from XCKD, but it's the Bobby Tables, little Bobby Tables strip. So there's one thing that's not right, though. It's a great, very famous. But I crossed out this part about. I hope you've learned to sanitize your database inputs, because that's not how you stop cross-site scripting. So in this example, SQL injection. talking about SQL injection. You don't stop SQL injection by sanitizing inputs. You stop it by parameterizing queries. So I love this comic, but it's unfortunately not quite right technically. So I think the best way to illustrate parameterizing queries is with a code example. So I have some Java code here, and we have a couple of inputs coming into the application from the HTTP request. We have a new name parameter, and we have an ID parameter. And those get stuffed into a couple of variables, a string variable and an integer variable. And then string concatenation on the third line is being used to build a SQL query. And so this is the very insecure part. The new name variable and the ID variable are not trusted. They're coming in from the user in an HTTP request. And so if they are crafted, if that data is crafted in just such a way, the user can modify the SQL query and do nefarious things. So this is really the heart of SQL injection here. It's the string concatenation code. So let's look at a equivalent with using parameterized queries. And so again, this is Java. So in the Java world, we want to use an object called prepared statement. So in this case, we still have inputs coming in, new name and ID, and they're still added to a couple of variables, new name and ID. However, the big difference here is that a prepared statement is instantiated here, and a string is passed in called update employees set name equals question mark where ID equals question mark. So this is where the query is getting parameterized. In other words, the parameters are the name and the ID, and so that's the question mark. The question mark are basically placeholders for the actual data. And so in the last two lines, you see that the placeholders are getting set to the actual values using a set string and a set int call. So the one simply the one here under set string, that just is referring to the first question mark, and the 2 on the set int is referring to the second question mark. And that's pretty much it. You're 100% protected against SQL injection here, because essentially the statement is fixed and can't be changed. The only thing that can be changed is the data in the question mark, the placeholders. So that's parameterizing queries. And there's equivalent in the .NET world, the PHP world, there's equivalent statements. Parameterizing queries is kind of the generic way to say build your SQL statements securely. All right, so the number one proactive control. Let's see how I'm doing on time. Getting close here. Is verify for security early and often. So this is talking about testing. Make security testing an integral part of your software engineering practice. There's different approaches to testing. You can do manual testing, dynamic scans, static code analysis. They're all complementary and all valid testing approaches and complementary in many ways. As far as what to test for, OWASP has a guide called the Application Security Verification Standard, which is the ASVS. That's a really great document. Along with proactive controls, I highly recommend the ASVS. It's a guide for saying, what do you test? If you don't know what to test for, if you don't know what vulnerabilities I should know about, the ASVS has all that for you. Really good document, works well with the proactive controls too. And so another recommendation is automate the scans. So manual testing is expensive, it takes time, you can't get through. You may have thousands of web apps or any kind of applications that need to be tested, so you should automate. Leverage APIs, leverage scanning tools, integrate with your CI/CD environment. So get the scans automated as much as possible. So challenges. For this control, even though it's number one control, there are challenges, including modern web app technologies, microservice architectures, which make static analysis much more difficult, because static analysis works great with a monolithic application where all the code is there. You can track the data flow through the application. With microservices, it's much harder for static analysis to do that. Pen tests are costly. The testing can slow down deployments, make things slow down in general. You need specialized skills as a manual pen tester. You do need to know how to do that. That's a specialized skill, which leads to why it's expensive. New types of vulnerabilities are being discovered. I mean, just for last month, you know, I mentioned the struts. More recently, toward the beginning of this year, there was a PHP serialization vulnerability, like the bug bounty security researchers looking at the Pornhub website, that $20,000 bounty for this PHP deserialization vulnerability. All these things are coming out throughout the year, so you have to keep up with them. And that leads to a problem with testing coverage. So my only pitch for Qualys here is that we do have a tool to help with that. We have a cloud-based scalable solution. It's a dynamic testing tool. Full API for automating scans and scheduling scans, so you can help get the coverage and testing that you need. So anyway, I'm going to wrap up here. The proactive controls, I just listed them here again as a summary. But if you do adopt these controls, most likely you can stand around and smile like these people. So at least that's the goal anyway. And so final word is, you know, what's going on with proactive controls in terms of future development. So like I said, I've already talked to the primary authors of the proactive controls, which you can download here. They have an update coming this year. And so interestingly, I'm going to be in contact with them, talk to them. For this talk, I have some ideas that I wanted to throw into the proactive controls, but I actually recommend it. As far as developer-centric type of list, it's much better than the OWASP Top 10, especially with the new controversy going on right now. We don't know what's going to go on with the OWASP Top 10. Document over the years, helped raise awareness. It's really an awareness document, whereas this is more of a, a practical guide with real solid advice for development teams. And that's all I had. Thank you, everybody. Appreciate it.